Welcome to the Senior Design Project, Load Profiles of Customer Classes and Feeder Voltage Profiles. Team members, faculty mentors, and industry supporters can be viewed at the top of the poster. For this project, we looked at the Oakwood 1204 feeder, comparing DMS load schedules and AMI data to help generate improved load curves. Duke has determined that the current DMS profiles need to be updated to enhance the accuracy of curves. Important terms of the project are outlined in the explanation of terms.
Here are the deliverables that are expected of the team. In beige are the tasks in progress this semester, in green are those being researched, and in red are the topics to be worked on next semester.
In order to compare the existing DMS schedules versus the AMI measurements, millions of lines of AMI data were processed. Figure 1 details the generation of the existing DMS schedules and the average AMI profile for each load modeled by the DMS. An analytical process using the AMI data was employed to generate 40 new DMS schedules for each load category, season, and day type combination. Figure 2 illustrates the process used to either disregard or repair gaps and perceived bad data in the AMI dataset. In order to compare the accuracy of the original and improved DMS schedules with respect to customer usage, mean absolute error and mean absolute percent error were computed for each load. The analysis is pictured here for a single season day type combination. Figure 3 gives a visual representation of the MAPE per transformer of the original and improved DMS schedules. The warmer colors in the original DMS schedule portion at the top of the graphic indicate higher error relative to the improved section at the bottom. Figures 4 and 5 show the errors per load category for the original and improved DMS schedules respectively. In Figure 5, using the improved schedules has moved the majority of the loads closer to zero error.
It is important to note how the improved profiles affect the load in the aggregate and not just at the individual load level. Figure 6 represents the aggregation of the individual loads into a sum profile, shown here cycling between all 8 season/day type combinations. It can be noted that the original DMS schedule overestimates the actual usage given by the AMI measurements and that the improved load schedules mirror the AMI measurements.
With the results obtained this semester, there is a chance that the creation of new load schedules isn't necessary to improve the DMS schedules, and that a more direct solution would be the implementation of a global scaling factor varying by season. For the next phase of this project, we will explore this potential solution and begin analyzing the effects that behind-the-meter resources have on load schedules and develop a method to detect these loads. By the end of the semester, we expect to have an automated tool paired with the GUI that generates the new DMS schedules. The team gratefully acknowledges the support and guidance of the faculty mentors as well as the industry supporters.